Welcome to this video, which I've labeled lecture 2, where we are going to look at the properties of limits. So in the previous video, lecture 1, I introduced the concept of limit and we understood what limits are. We'll later on go ahead and evaluate them, but before then, we need some properties as we begin. So to discuss these properties, we are going to consider two limits just for help us be able to come up with the properties. We are going to consider the values, the limits of two functions and their values. So we are going to assume that if they exist, the following limits. So the first one, we are going to say that if you have to evaluate a limit of a certain function f of x as x tends to a, then the value of this limit, we can call it just f. It's a number, just f. So this is like f of x. F of x is the function. It can be x squared, can be x cubed, 4x squared, doesn't matter. Then the x tends to a just a number like 1, 2, or 3. So the value of this limit, we let it be f if you have computed it. Then you're also going to consider a second one, maybe limit of g of x. G of x is another function which is also of x, function of x, as x tends to the same a. So we can say that the value of this limit, let's say it is g. So with these two, if these limits exist, because it is possible limit may fail to exist. So we are saying that if the limit exists, then the following properties hold. The following properties hold. And just to let you know, these properties are the ones that define the limit of the sum, the limit of the difference, the limit of the product, and the limit of the quotient. So those are the things we need to study, or maybe the properties. So the first property, 1, we are going to say that suppose the limit that deals with the sum or the difference of the two functions. So somebody asks you to evaluate a limit of these two functions added together or subtracted, f of x plus or minus the limit of this other function, like that, as x tends to a. So this one is identically equal to the limit of g of x, the first function, as x tends to a. Then you can do the plus or minus the limit of the second function. What we will call it, if you are doing the number theory, you call distributive property. But in this case, just evaluate the limit of the first and the limit of the second. So this is the limit plus the limit of the second function. So this was f of x. Sorry, this was f of x. This is g of x, as x tends to a, like that. So this one, limit of f of x as x tends to a, we had said that the value, let it be f here. And then the limit of g of x as x tends to a, we had said to let it be g. So meaning that you can get the value of this, and therefore this is just equal to f, which is the limit of f of x as x tends to a, plus or minus the limit of g of x as x tends to a, and we said it is g. So just getting the sum or the difference of the various limits. And of course, this one, as we are going to see later, can come as an example this way. Maybe somebody tells to evaluate the limit of x squared, maybe plus x, as x tends to a certain value, let's say 2. So this one you can evaluate by just doing some direct substitution. We are going to see that in the next video, but you can have these 2 placed here, so it will be 2 squared plus 2. So this will give us 6. So you can see I've just gotten the limit of this one, which is 4, and then the limit of this one as well, which is 2, and then if you add this, you're supposed to get the 6. So that's the first property that we need to understand. So the property of the sum or difference of the limits. So the second property that we also need to consider, so 2, the second property is the one that now deals with the product. So for the product. So the product, we are going to say that suppose you are to evaluate the limit. Suppose you are to evaluate the limit, and we can say the limit of this function f of x times g of x as x tends to some number, let's say a. So this one will just be equal to saying the limit of f of x as x tends to a, then times the other limit, the limit of g of x as x tends to a. And this one, from the previous work, the limit f of x as x tends to a, we had said it to be f. So then the limit of g of x as x tends to a is g. So just multiplying the two. So if you have for the two functions, you just need to multiply, and then you'll be able to get the correct answer. So that is the one for multiplication. Then the third one, the third property is the one that deals with the quotient. So for the quotient, we say that if you have the limit of f of x, then we are dividing by g of x. So this one is a function together as x tends to a is the same as evaluating each limit, the limit of f of x as x tends to a, then you divide, get the answer, then divide by the limit of g of x as x tends to a. So that is basically equal to the value of the limit of f of x as x tends to a, we had said it is just capital F, and then the limit of g of x as x tends to a, we had said is just g. So this is the answer. But something you have to keep in mind, remember that g in this case is not allowed to be equal to 0, because we know that if we divide by 0, we'll be tending to infinity. So we are not allowed to have g being 0. G can be any other number, but not 0. So it's not 0, not equal to 0. So that's the second, the third. The next, or the fourth property, we need to look at is the one which deals with the power. So limit of a power of functions. So let's say that you have something like this. The limit of f of x, then this f of x is just another g of x. So as x tends to a. So this one here, you are having a power there. So in this case, again, it's the same thing. Just evaluate the limit of f of x as x tends to a. Then we raise to the limit of g of x as x tends to a. Now let's look at what this will give us. The limit of this one, limit of g of x as x tends to a, we said it is g. So if this is g, then we can rewrite our equation, our property as this: f of x, x tends to a. This one we are raising to power g, because g is the value of this limit. And similarly, the value of this we also have is supposed to be f. So if that's the case, then it means that this one, all of it should just be equal to f raised to power g, and that is the property.